Here's a question that we have. It looks like we're going to be using some half angle identities. We're given that cotangent of x is 12 over 5, and we're also told that x is between pi and 3 pi over 2. So here we're being told that x is in quadrant 3. So that's what this piece of information is telling us. X is in quadrant 3. This is going to be relevant because we're trying to find the cosine of x over 2. The x over 2 part says we're going to be using half angle identities. We're going to probably want to use a half angle identity with this. And we're going to need to know stuff about where x over 2 is. So if x is between pi and 3 pi over 2, there's going to be some half angle identities. There's going to be some square roots. There's going to be some plus and minus. We're going to need to know the quadrant of x over 2. So if x is between pi and 3 pi over 2, if I divide everything by 2, x over 2 will be between pi over 2 and 3 pi over 4. So we can see that x over 2 is going to be in quadrant 2. It's more than pi over 2, but less than 3 pi over 4. So somewhere between 90 and 135. So we can see that x over 2 is in quadrant 2. So cosine is negative. So these are just some things that we observe before we start getting into any of the calculations. Now we might not remember our half angle identities. Hey Siri, what are the half angle identities? Siri doesn't understand me most of the time. So we'll just do it kind of the old style, half angle identities. And we could just kind of like look stuff up. And then we'll see that so we'll see that cosine of theta over 2 is plus or minus. That's why we need to know the quadrant. Square root of 1 plus cosine theta over 2. So there's our half angle identity that we're going to use. Cosine of x over 2 is plus or minus the square roots of 1 plus cosine x over 2. We have cotangent of x is 12 over 5. The half angle identity for cosine, which is what we want to use, involves the cosine of x. So I'm going to use the cotangent of x to get at the cosine of x. So since we know that cotangent of x is 12 over 5, we'll set up a right triangle. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. So we're going to set up a right triangle where 12 is adjacent and 5 is opposite. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So here will be x, and adjacent is 12, and opposite is 5. Then we'll use the Pythagorean theorem to find out our hypotenuse. So the hypotenuse is the square root of 5 squared and 12 squared. So 13. Isn't 5, 12, 13 a Pythagorean triple? So we'll do the square root of 5 squared and 12 squared and 13. 5 squared and 12 squared is 169. Square root of that is 13. So now we have the hypotenuse. So from there, we can write down the cosine of x is adjacent over hypotenuse. So we use some right triangle trigonometry to take our cotangent of x and figure out the cosine of x. The reason that we want cosine of x is because that's the one that appears in the half angle identity for cosine, and we're trying to figure out the cosine of x over 2. So now we can grab our half angle identity, cosine of x over 2. Since we know that x over 2 is in quadrant 2, we know we're going to want the negative, because cosine is negative in quadrant 2. So I'm going to want the negative square root. And then we have the square root of 1 minus 12 over 13. All, 1 plus 12 over 13, all over 2. We look at our list of answers and say, ah, crud, this has been simplified. So we're going to have to simplify this. Once again, we have a complex fraction. I got a fraction in my numerator of my fraction, and we don't like that. So I'm just going to multiply under my radical, just take care of everything under here first, by 1. So 13 over 13. So that'll give me 13 plus 12 over 26. And there's the 26 that keeps showing up in all of our answers down below. And then 13 plus 12 is 25. So we have negative square root of 25 over 26. So that's not what I wanted. Why is it giving us, where did this 1 come from? Oh, so even if we rationalize, this is not going to be. So we've got negative root 25 over 26. So it's negative 5 over the root 26. And if we rationalize, but that's not over. Did I get my identity wrong? Cosine is the 1 plus, sine is the 1 minus. Cosine is 1 plus, sine is 1 minus. And the problem did ask for shouldn't be, we should have, it should be the 5. Cotangent is 12 over 5, so that's adjacent over opposite. Adjacent is 12, right? come at it from another angle. So one of the things going on in Canvas, we're getting instead of a 5, we're getting a coefficient of 1. That comes from this 13 plus 12. If we do 13 minus 12, because we wanted sine of x over 2, then that would put a 1 up in the numerator, and that would give us the root 26 over 26. So I don't know if that's the disconnect or if we did something wrong. Let's find out. So if cotangent of x is 12 over 5, tangent of x is 5 over 12, and that tells us that x, well, at least the reference angle for x. Let's see, go into radians. The reference angle for x is tangent inverse of 5/12. So the reference angle is going to be 0.395. And x is in quadrant 3. So x will be pi plus the reference angle. So pi plus the 0.395. $3.536. So now that we have a value for x, we want the cosine of x over 2. So 3.536 over 2, and then cosine. So I'll do cosine of this number divided by 2. So negative 0.196. Is that the square root of 26 over 26? So I did in fact make a mistake somewhere. But where? Cotangent of x is 12 over 5. Cotangent is 1 over tangent. So tangent is opposite over adjacent. Cotangent is adjacent over opposite. Okay, so that makes the hypotenuse 13. Cosine is adjacent over hypotenuse, so cosine is 12 over 13. Cosine of x over 2 is plus or minus the square root of 1 plus the cosine of x, all divided by 2. And we double check the identity. Cosine of a over 2 plus or minus square root of 1 plus cosine a over 2. Anybody see where I went wrong? I can see this part of where I went wrong, this minus. If this is a minus, 1 minus 12 over 13, then I get 13 minus 12 over 26. 5.4. I thought they might have an incorrect answer as well, but then we just tried finding the actual angle. I put x in the third quadrant. I divided the x divided by 2, and then found the cosine, and that worked out to be root 26 over 26, and not negative 5 root 26 divided by 26. See, that's what happens when that's a problem. It's just like utter chaos in the rest. They don't even know why. And like, we don't know why we're freaking out. And then the other instructors. Right, but we want to find the cosine of x over 2, right? Cosine of x over 2, and the cosine of x is 12/13, and that shows up here. No, we're given cotangent, and we're trying to find cosine of x over 2. So I made a mistake somewhere, either in my calculation of cosine of x over 2 using the identity, or I made an error somewhere in here because cosine of x over 2, when we actually find out what x is, comes out to root 26 over 26. But I'm not sure what. Here are the possible places. Maybe I have the wrong trig identity. I calculated the hypotenuse and thus the cosine wrong. But I do not see it. I don't know. I know exactly why I don't see it because it's 2 o'clock in the afternoon and I'm never functional at this point of the day. Five root 26 over 26. Same. That's what we got. You are correct. Thank you. Oh, geez. So we are in X is in quadrant 3 and the cosine should have been negative. Whew. Andrew, save the day. So it is going to be negative root 26 over 26. Here's where I made the mistake. I have here cosine of x is 12 over 13, but where x is in quadrant 3, so it's negative 12 over 13. I drew this because I always draw this generic triangle, but I needed to draw the x in quadrant 3, so I should have drawn it this way, where our hypotenuse is still 13, but adjacent is a negative 12 and opposite is a negative 5 because x is in quadrant 3. So I was saying to myself, I'll just remember that x is in quadrant 3, and I should have a negative 12 over 13. Oops, a negative 12 over 13, and I didn't. So that changes this calculation. So when we have cosine of x over 2, I want negative square root of 1 plus negative 12/13. all over 2. And now that I have 1 plus a negative 12 13s, then my numerator is going, I'm still going to do the same thing, multiply by 13 over 13. But now I'm going to have 13 minus 12 over 26. It's still negative because this negative sits outside the radical. So that's going to be negative 1 over root 26. And then when we rationalize, we get negative root 26 over 26. That took entirely too long. Fine. Thank you. You just sitting on that, weren't you? That's because we were too close to the problem. What I should have done, the proper strategy, if this had happened during a test that was timed, incidentally, the proper strategy is to say, well, I can't see what it is, go do something else. And then when you come back, you will probably see right away cosine of x should be negative because x is in quadrant 3. No, I'm going to give you multiple opportunities to do the problem. So if you make a mistake, if it's something that I have to grade, then there'll be a schedule and you'll know when I'm going to grade it. So then I grade things. I'm going to grade things on Friday. So on Friday, your scores get updated, and then you can start over again, and you can do the problems again. Yeah, if it's a numeric answer, then you can put in your answer, and you'll know right away. And so you just, yeah, if it's stuff that you're typing in, then I have to look at it. But some numeric answers, if I say stuff like round to the nearest 100, that means you're going to be typing in a numerical answer, and I can have Canvas grade it right away. And if it comes back wrong, then you just try it again, and then you try it again, and then you try it again, and then you try it again, until it comes back right.
Should we all get A1?
I mean, if you keep going back and fixing things, if you give yourself enough time to go back and fix things that need to get fixed, then yeah. Unfortunately, I have to do the whole thing. So instead of having one big thing, I break it down into small parts. So they'll be the size of it. So it'll be like 3 problems. No, they'll be the same problem. I don't like problems. Generally, I prefer to have problems that aren't procedurally generated, because I don't like things that get generated. So for example, this choice here to make cotangent of x equal to 12 over 5 was specifically because 5 and 12 are 2 legs of a Pythagorean triple. You can't just come up with 2 random numbers because you want the opposite adjacent and hypotenuse to be all integers. That was part of the design of this problem. So if you tell Canvas just to make up 2 numbers, some people are going to get 12 over 5, so their hypotenuse is 13. But if someone has like 5 and 10, their hypotenuse is no longer 13. Their hypotenuse is the square root of something, the square root of 25. And all of a sudden, their problem is messier than someone else's problem. Yeah, I think this problem set is not procedurally generating problems, but we can't come up to a lot of times. You want to have variety, and you can tell the computer just throw some random numbers in there, which is generally kind of a bad idea. So, like if I set up a problem to just say, just give me a valid cotangent. Mm-hmm.
there was a problem. It had nothing to do with placing or. I'm really old.
Mhm.
So I was wondering, like, off of the grill, this is the bottom.
I don't remember that problem.
Yeah. I wrote down. I'm gonna go. No, it's a different one. It's on the. Well, there's a. But the annoying thing is, there's so many different of that. We didn't use any of that then. We didn't do that side. Well, there is a. But it's so like, it's a need to.
I don't remember the problem. I haven't looked at it in a while.
In theory, that's
Right. Any other problems? Question 3? Yeah. This? It's not glossy, but it's slicker than paper, but it's not as smooth as like a plastic sheet. So, yeah. You got to be careful how you clean it because the coating can get worn off. Yeah. Microwaving it will erase it. Microwaving it will erase it. You could also just wipe it clean, which I think it comes out cleaner when you do that. Also, if you leave it in your hot car, all the ink might kind of vanish, but you can put it in the freezer and it comes back. You can see it back again. Apparently, I don't know. I'll try to keep it clean.
This is the problem I was talking about.
Uh-huh.
This is an odd hot line.
Oh, okay. Okay, so an auger used to deliver grain to a storage bin can be raised or lowered, thus allowing for different size bins. So when I look at this part, I don't see any trigonometry. And this is one of the tricks in word problems. In a word problem, you have to remember what it is. What can I do with a word problem? Think about where you are. We're in section 5.4. We're talking about half angle identities. So I see this, I'm like, oh, okay, trig stuff. I don't know if we're trying to make trig relative to farming. But alpha is the angle formed by the auger in the ground for bin A such that now we get to a trig thing. Tangent of alpha is 40/9. Now I start to care. So 5, 4, 3. Tangent of alpha is 40/9. The angle formed by the auger and the ground for bin B is half of A. The angle formed by the auger and the ground for bin B is half of alpha. Sorry, I said A. If the height h in feet of a bin can be found using the formula h equals 75 sine theta, where theta is the angle of the ground formed by the angle formed by the ground and the auger, find the height of bin B. So the angle formed by the auger and the ground for bin B is half of alpha. So there's an angle running around here that is half of alpha. Theta is the angle formed by the ground and the auger. So theta is 1/2 of alpha. And we want to find the height of bin B. The height of bin B is h, and that's 75 sine of theta. We know that theta is alpha/2. So what we want to find is 75 times the sine of alpha/2. And we don't actually need to know what the auger is, because I cannot picture an auger, which is a big drill. But if you stick a drill in grain and just have it spin around, then a bunch of grain will come up the thing, so. Yeah, and there's like a tube, and it's like essentially a drill bit in a tube, and then as you drill, the grain gets pulled up from the bottom and then spat out the top.
I know what an auger is, but it's the auger that I'm used to because I work construction for this giant round field.
So what you do, so that you don't put a case around it. What you do is you just stick that in the ground, and what it's doing is grabbing the dirt underneath it and pulling the dirt up. So what you do is you put a case around the drill bit and stuck it in where you don't have to drill into the grain. You just stick it in the grain and start the drill. It does the same thing that the drill bit does. It grabs the stuff from the bottom and it moves it up to the top. Just like when you drill into wood at your house, the drill bit goes in, and because it's pulling wood, little wood bits out, and that's why you make a mess on the floor.
But it's a part that got me with the storage thing.
Right. So the important thing to do here is to ignore all that. See that we have tangent of alpha is 40 over 9. We want to calculate h. H is 75 times the sine of theta, and theta is the angle. And then when we go back, theta is half of the angle alpha. So those are the important parts. Tangent of alpha is 40 over 9. Auger and ground is half of alpha. Later on, they say theta is the angle formed by the ground and the auger, and that is still half of alpha. And the height is 75 sine of theta. Since we know theta is alpha over 2, now we know we're doing half angle stuff. And now the problem fits into here.
The auger.
They worded it. Yeah, it sits inside of a tube.
Look the auger to lift.
Yeah, see, it's just a screw in a tube. And then the screw turns, but it doesn't move anywhere. So all the stuff that it's sitting in, it pulls the grain out.
One knows it's not literally hard. Farmers now, and does but why would you have a question based off of farming?
I don't know, why would you have a question based on it, alpha anything? As far as I'm concerned, I could just say, I'd be like, oh, tangent of alpha is 40 over 9. Find sine of alpha over 2. And that would be the same problem.
Elevator.
See, the problem with elevators is elevators don't go off at weirdo angles. Elevators are just pretty much up and down. It's super boring. Willy Wonka's elevator does move at weirdo angles.
I would love to read it. Yeah, that's what.
See, the problem is when you do problems like this, so if you're like, oh, Willy Wonka's elevator goes at this angle, people would just immediately be like, oh, I've never read that book, right? And so what happens when you get into this, that kind of mindset is you see like auger, it's like, I don't know what this is. You're actually fighting against the non-relevant part of the problem. One of the points of doing this problem is not necessarily to make this a farming problem. So no one who was involved in the writing of this book said, we need to make this relevant to farmers. We're not worried about teaching trigonometry to farmers. We are worried about teaching trigonometry. And this problem here is essentially a reading exercise. Can you take a bunch of extra stuff around it and pull out what's important, like we did here? This is the important stuff. But if we can we spread that out all over the place and make and add one challenge on top of tangent of alpha is 40 over 9, find 75 times the sine of alpha over 2, right? So this problem with the farming is not taking this general problem and say, when is anybody ever going to make this calculation? Probably never. It's not about that. We know how high the bin is. That's probably something that we know, right? We know already what the answer is if it's something like, oh, how tall is the door? I can come up with a trig problem that says, oh, the angle from the floor to the top of the door is so many degrees, and I'm standing 20 feet from the door. How tall is the door? The practical answer to that is like, oh, dude, just go measure the door. If you know you're 20 feet away from the door, why don't you just use that, whatever you use to make that calculation, measure how tall the door is. The point is not figuring out how tall the door is. In a math problem, the point is almost never the answer to the problem. Coming up with the answer is not the point of the problem. Reading what's going on and taking what we know about half angle identities and trying to solve the problem, that's the point of the problem. So when y'all get into calculus, you're going to be finding derivatives. And in the beginning, finding derivatives is going to be super easy, barely an inconvenience. You'll be like, oh, this is easy, no problem. Only when the derivatives get really complicated are you going to say, dude, when am I ever going to need to find derivatives? But that's an important cue. This is a useful cue. I'm not just making fun of students because students are like, oh, the teacher's like, oh, you have to do useless shit. That's not the point. The point is, when you start wondering, what's the fucking point of this? You need to realize, I have just been challenged by the math problem. I now have to start doing work. If you've never wondered, like, wow, what's the point of this stupid problem? You're probably not struggling with the problem very much, right? If I had a quiz that was like, oh, 2 plus 3 equals 3 plus 7 equals, and it was just like a bunch of adding one-digit numbers, no one would really question it because you wouldn't be challenged, right? But if I'm like, oh, augers at angles and saying things all fucking weird like this, you're like, oh, dude, when am I gonna have to do this? The answer is probably never. You're not gonna be like some farmer and say, oh gosh, I wonder what the angle is. How high has this been? This is the angle between the auger and the ground. I go, well, Farmer Bill, what do you know? Well, I know the tangent of the half of twice that angle is 40/9. And like, oh, dude, the fuck? How do you know that? It's like, oh, I have some weird fifth dimension perception. That's the only way I can see numbers. I don't like look at this and say that's 20 feet. I don't look at this angle and say that's 30 degrees. I say the tangent of that angle is 40/9. Wait a second, what? And then you find out the origin of Farmer Bill was that he was a character in a trigonometry book, and this is why he is this way. And then some wizard came along and said, I'm tired of making creating undead creatures out of bones that I found on the ground with corpses, getting zombies and skeletons. Super boring. I'm gonna make a farmer out of this character in the book. And then they just unleashed that onto the world. Farmer Bill, how high is bin B? The tangent of twice the angle from the ground up to the top of the bin is 40/9. Oh, this could be good deflection, right? It's like if you're walking through a city and you don't want to talk to people, talk to yourself and be mad about it. And people won't bother you. Like if you're worried about people, like if you're walking through a place where they're going to be like, oh, trying to take a survey, just talk to yourself and be mad about it. And they won't talk. They'll be standing there with the clipboard, like, oh, looking for the next person that wants to take a survey. Hey, would you like to take a survey? No. Hey, would you like to take a survey? But if you're walking by and like, no, I'm not doing that. And you're like talking to yourself, they won't talk to you. They'll leave you alone. Anyway, we have sorted out the important stuff. We know that the tangent of alpha is 40/9. That's going to give us sine, cosine, tangent of alpha, whatever we need. In particular, we need sine of alpha over 2. So we're going to use the half angle identity that says sine of alpha over 2 is plus or minus the square root of, and I'm just going to look it up because I don't like remembering things. Sine of a over 2 is plus or minus 1 minus the cosine of a, alpha in this case, over 2. All right, so we'll use our Tangent of alpha is 40/9, so this is opposite over adjacent. Oh, and we're in the all these angles are going to be positive, so I'm just going to draw it like I normally do and not get tripped up by weird quadrant things that I'll forget about. So here's our alpha. Opposite is 40, adjacent is 9. So our hypotenuse is, how much is it? So square root of 9 squared and 40 squared. 41. 9, 40, 41, also another famous one. Yeah, this is a Pythagorean triple. Anytime you have an odd number, you can make a Pythagorean triple. Take the odd number, square it. 9 squared is 81. Cut that in half. 40.5, round it down, round it up, you have a Pythagorean triple. 7 squared is 49. Cut that in half, 24.5. 7, 24, 25. Pythagorean triple. The one we had in the previous problem, 5, 12, 13. 5 squared is 25. Cut in half, 12 and a half. 12, 13. 5, 12, 13. Pythagorean triple. That's one way to make Pythagorean triples. More importantly, we have a way to make the cosine of alpha. Cosine of alpha is adjacent over hypotenuse. And so now if I want the sine of alpha over 2, I don't know how high we're raising this thing, but I don't think we're raising up so much as flopping over to the other side. So I'm just going to go with the positive. Square root of 1 minus 9 over 41 all over 2. We don't like complex fractions. Well, I do. I don't know about y'all. So we'll multiply by 41 over 41. So we'll have 41 minus 9 over 82. This is all still in a square root. So we'll have the square root of 41 minus 9, which is 32. Now we do want 75 of this because the height is 75 times the sine of alpha over 2. So the height is 75 times the sine of alpha over 2, which is the square root of 32 over 82. Then we look at the problem to see what our instructions are for answering. This is the exact value, although not simplified. It says round your answer to the nearest integer. So I go, awesome. I just need to grab my calculating machine and figure out what 75 times the square root of 32 over 82 is. So to the nearest foots, 47 foots. Any questions? Always look at what you're given and then look at what you're going for. Here it was just phrased in a really weird way. This is magician style problems because that's what magicians do, right? They're trying to distract you. So while I'm doing sleight of hand over here, I'm making you look at this hand by having flash paper going pow. Or in the traditional magic act, the magician is standing there, they're going like posing and like this. Meanwhile, the assistant is furiously working behind the scenes to do all the stuff. So like we lower the screen and the assistant is behind the screen doing all the work while I go with the music. And then I come over here, bam, and I just pose outside of the screen. My assistant is back there going, oh, son of a bitch, doing all the work. Yeah, whose name is on the marquee? Yeah, that guy. Magician problem. Let's take a break, get some water, look up more pictures of augurs.